In Pennsylvania, a historic bridge does battle with Mother Nature.
Oh, man!
It was like listening to a train wreck.
A New York neighborhood is rocked by a construction catastrophe.
I don't know what's going on, but it's big.
Somebody came in and said, house collapsed.
In Naples, disaster nearly destroys a hospital.
People thought a bomb had gone off.
And in the UK, a key viaduct starts cracking at the seams.
There was all sorts of people working 24 hours a day, floodlights, the lot.
With big builds, even the smallest mistake can be a huge disaster. From miscalculations to misunderstandings, some with deadly consequences. These catastrophes are every engineer's worst nightmare. Even with the strongest structures, engineers are in a constant battle with the forces of nature. Underestimate their power, and the results can be catastrophic. Like this disaster in Pennsylvania. Dramatic destruction that caught a city by surprise.
This lady starts screaming, "The bridge is falling, the bridge is falling."
A landmark crossing torn from its foundations.
I never thought something that was so solid could possibly be swept away. It really scared me.
As Mother Nature goes head-to-head with engineering.
It was a demonstration of the power of water that I had not seen before.
Harrisburg, as Pennsylvania's state capital for more than 200 years, it's divided by the river that runs through it, the Susquehanna. Sue Yenchko is a long-standing resident of the West Shore community.
We are on the west shore of the Susquehanna River, and Harrisburg proper is on the east shore. Most people think Philadelphia is the capital, but it's Harrisburg. That's where the Capitol and all the state government buildings are. There are a lot of state employees who come and go from the east to the west shore.
With many bridges now spanning the river, commuting couldn't be easier. But back in the 1800s, there was only one option. The Market Street Bridge, and crossing it wasn't cheap.
With only one bridge over the river here, owners had a monopoly. And for 70 years, they could effectively charge as much as they wanted for people to use the bridge.
People were really getting fed up with the ever-increasing toll prices to cross the bridge, and from that disquiet came the People's Bridge, to show the people were going to have their way to get into Harrisburg, too.
Like many crossings of its day, the People's Bridge, also known as the Walnut Street Bridge, would be a through truss design. But crossing the wide and mighty Susquehanna with steel would be no walk in the park. So, as State Museum curator Robert Hill explains, engineers took advantage of the natural midstream city island.
The river's about 3/4 of a mile wide in this area, and because of that, City Island was used as a midpoint for the central section. So it's not really one bridge, it's two bridges with the embankment in between. You have one bridge that runs from Walnut Street, where the name comes from, to the island, and then another section that runs from the island to the West Shore.
The two halves of the Walnut Street Bridge combined were more than 800 meters long, made up of 15 wrought iron spans, 8 to the west of the island and 7 to the east, all supported by huge stone piers.
Opening in April 1890, the Walnut Street Bridge was an immediate success, charging just 2 cents to cross, which was less than half the cost of its rival. And the people loved it.
It was a much more picturesque bridge because there's a beauty to the design. And so it really was the future.
This futuristic bridge carried people to and from the capital for more than a century, until one very harsh winter. January the 20th, 1996, an unprecedented cycle of freezing and thawing left its mark on Harrisburg.
The winter of '96 had been very severe. About 2 to 3 feet of snow had come down, and there was a great deal of ice on the river, combined then with the problem of a heavy rainstorm that thawed the snow, flooded the river, broke up the ice so that it put all of that tremendous power of flowing water up against the bridge.
With the floodwater rising, huge chunks of ice were now pressing hard against the top of the 106-year-old Walnut Street Bridge. Local resident Teresa Irvin McCurdy was filming the icy river.
There wasn't really a lot to see at the time, and this lady starts screaming, "Bring the camera, the bridge is collapsing, bring the camera!" And I'm like, what? And as soon as I saw it, I just zoomed right in on what was happening and couldn't believe it.
Oh, man!
2 entire spans were being forced off their piers by the ice and water.
It literally was strong enough to pick up the bridge and carry it downriver. It was just an unbelievable sight.
From her apartment overlooking the bridge, Sue Yenchko also witnessed the disaster unfolding.
I came upstairs to use the phone, and as I was talking, the pieces of the bridge started to move away from the bridge, being carried on top of the ice.
This was incredible. Not only had the massive wrought iron spans been shoved off their piers, they were now moving downstream on a raft of ice.
Residents watched powerless as the bridge was torn apart.
I did feel helpless because I said to myself, call 911, and I thought, what will 911 do to a bridge that is floating down the river?
Instead, Sue captured the catastrophe on camera. But from her vantage point, she feared the disaster was far from over.
It's gonna hit the other bridge!
I was afraid that it was going to topple the Market Street Bridge and keep going and topple the next bridge and the next bridge. I thought disaster was striking.
Ironically, it looked like the 2 spans were about to take out the crossing they had been designed to compete with.
When it hit the Market Street Bridge over here, it just let out this loud, crinkling sound.
It was like listening to a train wreck. I've never heard anything quite like that. I thought the bridge was screaming.
Amazingly, the Market Street Bridge stood firm against the huge collision.
As it hit the bridge, the current pulled it underneath the stone arches
and broke up into pieces and crumbled underneath.
In total, 3 spans of the Walnut Street Bridge were destroyed, lying in a twisted mass of metal at the bottom of the Susquehanna River.
The Walnut Street Bridge is part of the history of this area, so to see something like that get damaged so quickly and just disappear, that was very sad.
Luckily, no one was injured in the disaster, but a large part of the so-called People's Bridge was gone.
It was a shock. Still can't believe that, 1, it happened, and 2, that I was there to be able to film it.
As the waters subsided, many were left wondering whether the collapse was down to the elements or engineering.
The extreme conditions ranked among some of the worst the state had ever seen, from record snowfall to an unexpected thaw which sent snowmelt flooding into frozen rivers. There were huge forces at play.
All that power headed straight for the aging Walnut Street Bridge. Abdollah Shafizadeh is an associate professor of civil engineering.
There are 2 forces that are applied to bridges subject to flooding events. One is the drag force that is applied in the horizontal direction. And the other force that can be applied to bridge decks is the uplift force. Immense amount of forces are applied vertically, and it can lift the deck and lift it off from the bridge piers.
Due to its design, this bridge was more vulnerable to uplift than its neighbors.
The main force holding these trusses in place is essentially gravity. When they were built, engineers hadn't anticipated such extreme weather. So being shoved hard from one side just wasn't a factor.
A bridge typically is made to deal with forces vertically, what's on the bridge surface being carried down on the piers to hold it. This is then a horizontal force, and with ice there, now you have the force of the river building up behind it and continuing to push against it.
In a normal flood, water can work its way underneath the bridge. But here, huge slabs of ice were building up against the side, almost like a dam, focusing all that power onto the bridge deck.
If the level of the flood and the ice reached the deck, then that would apply immense drag forces and also uplift forces. And that can eventually lead to the collapse of the structure.
It was a demonstration of the power of water that I had not seen before. A great deal of water moving with incredible force against a structure that's trying to stay in place. And it was the irresistible force moving it out of the way.
As well as massive forces pushing against the bridge, something else may have been at play underneath. The scourge of bridge engineers across the world: scour.
Scour is one of the great dangers to bridges. Where water flowing fast around the base of the pier erodes the foundations. And here, it had been doing it for more than 100 years.
Scour is one of the main causes of bridge failure in the US. But with the fast-flowing river also heavily iced over, things were made a whole lot worse.
The problem becomes more severe when we have ice cover, particularly rough ice cover, which increases the velocity of the flow, and that can intensify the formation of a scour, in turn impact the integrity of the piers, move them away from their foundation, and then unseating of the bridge deck and eventually collapse of the structure.
In the end, the flooding combined with decades of scour proved too much for the century-old People's Bridge.
All of that tremendous power of flowing water, you could see afterward, had pushed those heavy stone piers quite literally back several feet before tearing the iron off the top of them and taking them down to the Market Street Bridge.
In the aftermath of the disaster, the Walnut Street Bridge was closed and the huge cleanup job began.
The next step, of course, was to make sure that the Market Street Bridge was still structurally safe, but then they also had to take up all the old pieces from the bridge up out of the water, since boats do go up and down the river.
And while the Market Street Bridge was given a clean bill of health, the People's Bridge wasn't so lucky.
The sad thing is, the cost of restoring the entire bridge was just too much to ever have it done.
Today, most of the bridge remains intact, serving as a constant reminder to the people of Harrisburg. Maybe one day, this historic crossing that stood firm for more than a century will rise again.
This whole event was extremely unexpected, and one in which I'll never forget.
It was a symbol. It started out as the People's Bridge because it's a beloved bridge, and it just got some teeth missing from it now.
In engineering, every part has to work together in perfect harmony. Overlook one piece and everything can come crashing down. Like this disaster in New York that struck a Brooklyn condo build.
I don't know what is going on, but it's big.
Somebody came in and said, house collapsed in Brighton Beach.
They watched it just pancake in on itself. It just sounded like an explosion.
engineering errors that ended in tragedy.
There was no warning and nothing anyone could do to stop it.
This must have been a cascade of failures. More than one thing had to go wrong.
New York City is world famous for its iconic Manhattan skyline, but it isn't actually the most populated borough in the vast city.
With more than 2.5 million residents, Brooklyn is the Big Apple's most populous borough. If it was a city in its own right, this would be the 4th largest in the nation.
And within Brooklyn, each neighborhood has its own distinct identity, like here at Brighton Beach. Pat Singer is director of the Brighton Neighborhood Association.
We're in the place that I love. This is Riegleman Boardwalk and our famous Brighton Beach. I fell in love with Brighton Beach coming here as a child. For me, it's been a kaleidoscope of experiences because it's ever-changing and just ever beautiful.
Local journalist Hannah Frischberg knows the area well.
Brighton Beach is definitely a different vibe than people associate with New York. People think of Manhattan, they think of Times Square, and they think of the big tourist hotspots. And then Brighton is very residential. People down here, they still got extended families living with them.
But in this fast-moving city, nothing stands still for long.
Demand for property in the 5 boroughs keeps growing, so developers are constantly working on new projects to bring more housing to neighborhoods like Brighton Beach.
In August 2011, work began on a new condominium in Brighton Beach. Adrian Brugger is a civil engineer.
It's a 5-story multi-apartment building with about 20 units and parking on the 1st floor. So this is what one would expect in developments in that area.
The structure was relatively conventional in layout. A concrete core surrounded by a steel framework of columns, girders and joists, onto which the concrete floor slabs would be poured.
Each steel and concrete floor would also double as the connection from the outer wall to the solid core of the building, tying everything together.
As structures go, this one was relatively straightforward. And in true New York style, it was going up fast.
4 months into construction, the first 2 levels were complete, as was the steel framework for the upper levels.
The construction at this time was progressing relatively quickly, as in the core of the building was already in place. This was concrete masonry unit surrounded by steel columns, and then light steel extruded sections on the outside. And at this time, the contractors were pouring the 3rd and 4th floors of concrete.
On November the 8th, contractors were on site to pour the 3rd level. At 2:30 p.m., disaster struck. Local resident Pat Singer heard the news.
I had a storefront office. Somebody came in and said, house collapsed in Brighton Beach, you know, and you, oh, but you couldn't get over there because there was so much ambulances and fire department, everybody over here.
The front of the building had failed catastrophically.
People who were in the area when the building went down said it was horrible. They said that they watched it just pancake in on itself. They said it just sounded like an explosion.
These workers were focused on pouring the concrete. They had no idea anything was wrong until the structure just dropped.
Tons of concrete and steel had collapsed. Emergency services worked tirelessly to rescue the workers, but for one member of the team, it was too late. Engineering professor Adrian Brugger knows the story.
Tragically, 1 construction worker lost their life and 4 more were gravely injured.
I think there are a lot of bad construction stories in New York. I mean, there's just a lot of construction in New York, but any time that something ends in a loss of life, it is a headline.
With the building in ruins, New Yorkers were demanding to know what had caused the catastrophe.
As a civil engineer, I know that for something like this, for a structure under construction to actually collapse to the extent that this has collapsed, more than one thing had to go wrong. This must have been a cascade of failures or bad decisions.
One of the most dangerous events in this type of construction is when the concrete is actually being poured. Suddenly, you have a huge amount of extra weight pushing down on the structure below.
If there's any weakness, there's a good chance this is when it will be exposed.
Investigators focused on how the structure had been held together.
One of the main reasons why this failure occurred is that the outer columns on the perimeter of the building were affixed to each other so poorly that they were not actually holding the building together laterally.
Here, the floor joists were a key connection between the columns supporting the outside of the building and the central core. But it turns out they were only loosely held in place.
The outer columns that are holding the periphery, where the facade would go, where the windows would go, were not properly fixed at the top and the bottom.
In places, the girders were held with only one screw, some with none at all.
When securing steel together, 2 screws will hold everything firm, but use just one and it can work as a hinge, making rotation more likely, which is bad news for stability.
So the slab itself is not actually connecting those outer columns to the core of the building, which, if you can think of the core very much like a spine of a building, it's sort of the backbone of the building. So you just have these lanky columns on the outside, and if they're not being restrained in any way, it's very easy for me, I don't have to put a lot of force on this to actually topple these columns over.
The steel structure couldn't handle the load of the concrete being poured above. As the weight of the slab increased, everything above the second floor began to move sideways.
Further investigations revealed another problem that had added to the instability.
When you're pouring a new slab like this, you have to pump tons of concrete from ground level up to the floor you're building. But the exact technique used here seems to have caused problems for the structure.
Normally a boom truck is used, so you would actually bring a truck in with a pump that has a large crane arm, essentially an articulated arm, that would pour the concrete straight onto the floor. Instead here, they actually tied that concrete hose to the side of the building, which sounds like it's not a big deal, but if you think about it, concrete is essentially liquid stone. So if you're tying a hose of considerable size to the side of a building, then you're actually putting an incredible amount of weight. You're putting vibrations and you're putting lateral force, sideways force onto a building where it is not designed to carry it.
The loosely connected structure was already being shaken by the hose, but one more factor was at play.
The straw that broke the camel's back was the fact that during the pouring of the concrete, the contractor chose to actually pour the 4th floor before they poured the 3rd floor. So you can imagine that this system is very unstable at this point. And once the concrete sets, it actually connects those outer columns with the core. But if you start top down, then that very unstable network just essentially is pushed to failure.
A combination of loose structural connections and an off-balance concrete pour brought this construction project crashing down.
Today, the plot remains vacant, serving as a warning to developers and engineers alike.
One lesson here is that no matter how routine or normal something might seem, any mistake can have devastating consequences.
Everyone wants their project completed on budget and on schedule, but in the end, we should always remind ourselves of the awesome responsibility as civil engineers and as builders that what we build is critical to life and safety of humanity.
Although the tragic event will be remembered in Brighton Beach, the community is once again looking to the future.
I'd like to see small houses come back in backyards and bring back the families into Brighton Beach. I mean, that's the future, the children.
When building big, engineers must always consider what lies beneath. Any weakness could trigger a catastrophe. Like this disaster in Italy.
People thought a bomb had gone off.
An engineering fail that almost swallowed a hospital.
Infatti si vede dalle immagini questi pilastri singoli che come dei funghi che escono dal terreno.
This was larger than an Olympic swimming pool and about 10 times deeper.
Just what had caused this massive chasm to open up? Naples, Italy's third largest city with around 3 million residents, is famed for its history, culture and natural beauty. Marco Caiano is a local journalist.
Napoli è una città speciale per tantissimi motivi, non solo per un qualcosa tipo il mare, il castello, il Vesuvio che abbiamo alle nostre spalle. Napoli è una città particolare perché è viva, perché ti riempie di amore, ti riempie di gioia, riesce a darti felicità con i suoi vicoli, con la sua pizza, con la sua gente.
Founded more than 2,000 years ago, Naples has always lived with the threat of disaster from its neighbour, Mount Vesuvius.
Vesuvius is famous for burying Pompeii almost 2,000 years ago. It's considered one of the most dangerous volcanoes on the planet, with 3 million people living close by. It last erupted in 1944 during the Second World War and is still active today.
Vivere all'ombra del Vesuvio per qualcuno è un'emozione continua, tendenzialmente per i giovani quello è un monte. Per chi invece ha vissuto l'ultima eruzione o per chi l'ha sentita raccontare dai propri nonni, è comunque un essere vivente che nel giorno in cui si arrabbierà con la popolazione metterà a rischio tantissime persone.
Building a city on this volcanic landscape has always been a challenge. Geologist Gaetano Sammartino knows what lies beneath.
Allora, innanzitutto c'è da dire che il territorio della città di Napoli è un territorio dal punto di vista geologico molto complesso. Questa complessità deriva da che cosa? Dalla presenza di 2 centri eruttivi differenziati, che sono i campi flegrei che stanno sul lato, diciamo, posto ad ovest della città di Napoli e il Vesuvio sul lato posto ad est.
Hemmed in by so much volcanic landscape, Naples really is on dangerous ground, but humans have added to the complications. The Greeks and the Romans dug networks of underground tunnels and cavities, and over the centuries, the city has continued to grow above them.
È una città bucata nel sottosuolo, come se fosse una grande groviera, e questa è anche un'attrattiva turistica incredibile. Infatti si fanno delle passeggiate enormi nel sottosuolo da una parte all'altra.
The fact that Naples has thrived for so long in this landscape isn't just a testament to engineers, it's a miracle.
Early morning on Friday, January the 8th, 2021, an emergency was reported at the city's Hospital of the Sea. Marco Caiano covered the story.
Era una giornata di gennaio mediamente fredda, buia. Alle 6:30 si è sentito un boato enorme e del fumo bianco si è sollevato da quel buco.
Marco approached the scene with caution.
C'era acqua ovunque perché i pompieri continuavano a lanciare dell'acqua nel fosso. C'era un odore acre, c'era tanto rumore di antifurti, rumore delle autobotti dei pompieri.
A giant chasm had opened up in the car park.
Un'emergenza può colpire chiunque e finire 20 metri sottoterra, coperto da alto terreno, magari in auto.
This was one massive crater. We're talking 2,000 square meters of car park, just vanishing into the ground.
This was an absolute disaster. The collapse cut power to a nearby COVID recovery center, forcing it to close.
In the early morning hours, the gaping hole had swallowed 3 cars. The fire department combed the debris with search and rescue dogs. Thankfully, no one had fallen with the vehicles.
La voragine che si è aperta, qualsiasi altra ora del giorno, avrebbe fatto contare i morti, perché quello è un parcheggio che vede gente che entra e che esce in continuazione. In quel momento non c'era nessuno, c'erano solo 3 auto, quindi immaginare l'esplosione, il crollo fatto alle 12.
With With the hospital car park in ruins, Neapolitans wanted to know what had caused the collapse.
Dalle prime voci, quando chiaramente circolavano questi WhatsApp sui cellulari di tutti, si è pensato a un attentato, a una bomba, a una fuga di gas, perché il boato era stato fortissimo.
Witnesses reported hearing an explosion at the same time as the sinkhole opened up. But engineers quickly established that was the roar of the ground collapsing.
In this famously unstable landscape, was nature at fault?
Since the late 1800s, the Naples area has suffered around 200 sinkholes, swallowing everything from trees to vehicles and threatening to destroy some of the city's most historic churches.
Within the wreckage, there was clear evidence that this was no natural sinkhole, but the collapse of a man-made underground room. Vincenzo Nunziata is a structural engineer.
A una certa profondità rispetto al livello del parcheggio c'era questo solaio su cui gravava tutto il peso del terreno e del parcheggio stesso. Quindi il solaio con i suoi pilastri sosteneva questo carico.
Looking at the videos, you see the slab is smashed at the bottom of the sinkhole, but rows of columns are still standing upright in the debris. And for engineers, that suggests a type of failure known as punching shear.
Si vede dalle immagini questi pilastri singoli che come dei funghi che escono dal terreno. Sopra questi pilastri c'era il solaio. Su questo solaio c'era un carico che era il carico del terreno più la massicciata del parcheggio. E probabilmente si è verificato o che il carico era troppo elevato o qualche altra problematica che ha comportato appunto la rottura in appunti singolari.
Punching shear is a danger to all slab and column structures. If the slab is overloaded or the connections are overstressed, the columns literally punch through the slab and everything above it collapses.
That explained how the slab had failed. The next question was why. Although investigations continue, one theory is that excess rainfall had shifted the ground above the slab.
Quando piove in maniera molto copiosa, chiaramente quest'acqua, essendo favorita dalla mancanza del terreno di avere la capacità di infiltrarsi, quest'acqua defluisce in maniera molto veloce e si concentra in aree molto ben definite. Quindi la concentrazione di questi volumi idrici può creare delle erosioni localizzate che possono favorire, diciamo, l'innesco di queste voragini.
And as the weight shifted above, the slab collapsed.
Whether triggered by weakness or excess rainfall, the point is that there were massive unanticipated forces working on the connections with the columns, and the slab failed.
After the collapse, the sinkhole was cordoned off for further investigation, and engineers declared the Hospital of the Sea safe. But the events of that day serve as a reminder that Naples will always be living with extreme forces of nature.
Napoli è una città dove l'uomo l'ha fatta da padrona sulla natura, creando non pochi problemi proprio quando la natura poi si ricorda che deve fare la natura, quindi quando ci sono delle forti piogge, quando ci sono degli acquazzoni, quando ci sono le grandinate, quando c'è il forte vento.
Like any disaster, this was a reminder of the huge challenges engineers face every day as they strive to keep our modern world turning.
When big engineering fails, the cracks can be obvious for all to see. But sometimes the threat can lie hidden from sight for years. Like this story in the UK, a vital flyover that was close to collapse.
This is one of London's busiest roads.
The traffic just came to a standstill.
Near disaster on the eve of the London Olympics.
There was all sorts of people working 24 hours a day, floodlights, the lot.
This hidden fail had potentially deadly consequences.
Concrete cracking and cables snapping. This was really a close call.
London, England's ancient capital, grew from a Roman settlement into one of the busiest cities on the planet, complete with one of the biggest urban headaches, traffic.
London is famous for its traffic. It's one of the most congested cities on Earth, and one of the worst offenders is the A4, the major artery running west from the city centre.
In the 1950s, the London suburb of Hammersmith was a major bottleneck, and the A4 was in desperate need of more capacity.
This part of London was already fully developed and squeezed on one side by the Thames, so there was no room to build a wider road here. Instead, they went up.
In 1959, to carry traffic over Hammersmith, work began on a more than 600-metre-long elevated roadway. Richard Farthing lives nearby.
It was built to relieve all the traffic. Because this is such a major interchange going north, south, east and west, it all had to go around the Broadway. And now the east-west traffic all goes over the top here.
Ever since, the 16-span viaduct has been known as the Hammersmith flyover.
It's vital because there is no other real way by road to get into London.
When it came to construction in this densely packed urban landscape, engineers had to get creative and precast the viaduct in small segments outside of town.
Because of the space constraints, the segments were cast miles away before being shipped to the construction site and lifted into place. A bit like flat pack furniture. But if something went wrong with this structure, people's lives would be on the line.
The viaduct was built from 202 segments, alternating between full-width beams and smaller boxes, working like a skeletal spine of hollow concrete. Then everything was held together by long steel cables, each nearly 3 centimetres in diameter.
The key to this structure was the tension from those steel cables. It held all the individual precast sections together so they could effectively work as one long bridge.
The flyover took just under 2 years to build and opened in November 1961. Ever since, it has been a key link between the city, its suburbs, and the rest of the UK.
When it was built, it was pretty divisive. It goes right through the middle of Hammersmith, but now, of course, it's been here 60 years. It's just part of the furniture.
The viaduct might not be as striking as some of London's other bridges, but when built, the structure really was pioneering. And ever since, it's played a vital part in the capital's road network.
Yet in 2009, routine inspections revealed that all was not well with the viaduct. Structural engineer Mirdad Mehrabani knows the case.
An engineer went to the site inspection and they realized that there are some problems. So they started intensive monitoring and realized that the bridge is really going to the state of collapse.
The problem stemmed from a protective coating on the tensioning steel cables inside.
Engineers knew that leaving the steel cables exposed inside the decks risked corrosion from atmospheric humidity, so they were encased in a concrete grout. The theory was that they'd be safely sealed away for life.
But in reality, the concrete was cracking and allowing water to corrode the steel cables. But in this pioneering structure, it was almost impossible to see how bad the problem was.
Breaking open the concrete would potentially make things worse, so first they used acoustic monitoring to listen out for cables snapping.
So in 2010, when they started intrusive monitoring on that, they realized that the speed of the wire losing per day was 1 wire per day, which is very fast.
In just over 3 years, they heard more than 1,000 breakages.
The good news was that the acoustic sensors could pinpoint the exact location of the snapping. The bad news was what they found when they got there.
Now that they knew where to look, engineers physically inspected the cables, and what they discovered was worrying. They found voids in the protective concrete grout and corrosion in the cables themselves.
Any corrosion would compromise the cable's strength.
They realized that these tendons doesn't work anymore, so it is just breaking and failing during the stress and tension. There's going to be some safety issues here.
The structure's integrity was totally dependent on the steel cables maintaining tension. Any reduction could be catastrophic.
Engineers knew the viaduct was severely weakened. And worse still, London was about to be in the world spotlight, with lives depending on this major roadway. The 2012 London Olympics would bring a massive increase in traffic, as athletes, officials and sports fans crisscrossed the city. So in December 2011, the decision was taken to close the flyover and figure out a solution.
The flyover closing was pretty dramatic because it was done with very, very short notice. We didn't know that there were problems with it, and then suddenly the Olympics were coming along and it got closed in a matter of weeks almost.
The bridge and potentially the Olympics were hanging in the balance.
There is an Olympic requirement to get to a venue in, I think, 45 minutes, and there was no way that they were going to get to the events without this flyover.
The cracked concrete explained the cause of the corrosion, but not why it was so advanced.
The level of deterioration was well above what had been allowed for in the designs. Something must have caused the steel cables to corrode rapidly. The question was, what?
One suspect was a built-in heating system designed to keep the bridge deck ice-free in winter. Keith Whitehouse is a local historian.
The flyover was built with underfloor heating, but the first year it was open, 1962 to 63, the council had a whacking £100,000 bill for the electricity.
With energy costs skyrocketing, authorities abandoned the built-in heating system for more traditional methods, like de-icing salts.
Back in the 60s, the plan was for the internal heating to keep the viaduct clear of ice. But when the de-icing salt started to be used instead, not only was water getting in through the cracks, it was now salty, which is a corrosive cocktail for steel.
When it rained, the salt was washed into the structure of the bridge, causing serious corrosion.
The fact the bridge was leaking was compounded by poor drainage, and the steel had been under attack for years.
It's so lucky the engineers realized how serious the problem was before anything failed. But now, the challenge was how to fix it.
With the Olympic Games just around the corner, a solution was needed and fast. But this pioneering viaduct had always been held together from within.
It wasn't possible to replace the cables inside the structure. So instead, they bolted on a kind of exoskeleton of new cables to keep everything properly tensioned in place.
So they used additional tendons outside of the bridge, but because that post-tension cable needed to be completely merged with the existing concrete, that they needed a new technology. So that new technology causes ultra-high performance fiber-reinforced concrete.
Not only is the new fiber-reinforced concrete highly crack-resistant, by being strapped to the outside, it's also easy to keep an eye on.
Any problem, you can monitor it in real time, and then if there is any problem, you can fix it before it is going to be too critical.
The solution wasn't just ingenious, it also extended the lifespan of the 5-decade-old structure by another 50 years.
Phase 1 of the repair was completed in time to reopen for the London Olympics.
There was all sorts of people working 24 hours a day, floodlights, the lot. It just had to be done.
By August 2015, the project was fully complete and the A4 was flowing smoothly again.
Most of us take bridges for granted. They're just there to do a job. But this is a reminder that in reality, the structure is battling huge forces 24/7, and nothing can be left to chance.